Hello everyone. In this presentation, I will be talking about the classification of cultural heritage images using decision trees in VICA. First, I will introduce you to the topic of this research, followed by the presentation of the data used in this research. Next, I will be talking about the applied methodology, followed by the discussion of the results and conclusions. The purpose of image classification is to group images into categories based on their features. With the growing need for digitization, especially in the domain of cultural heritage, where we are trying to preserve as much of the data from the past as possible, image classification has become one of the main focuses of research. To classify images, we can use different types of algorithms, but in this study the focus was on using decision trees as they can handle different types of data and they are easy to interpret because their interpretation follows an if-then logic. Image classification usually requires large sets of data in order for the algorithm to recognize the patterns from the image and thus perform accurate classification. But this is sometimes not the case, as the samples can be quite limited in size and not enough for building a good model. In some cases, we can increase the number of samples artificially or by collecting more data, but sometimes that's not possible, so we have to find a way to classify the samples that we have. So the aim of this research is to observe how well different decision tree algorithms perform on a small sample size. The images used in this research were obtained from Flickr and Google, and before classification, they were resized to the size of 150 times 150 pixels. The dataset used in the research included 150 color images belonging to three classes, mainly archaeological sites, frescoes, and monasteries. The feature extraction and image classification were performed in VICA, which is an open source data mining software. And feature extraction was performed using the image filters in VICA, mainly the fuzzy color and texture histogram filter, the edge histogram filter, and the JPEG coefficients filter. Four decision tree-based algorithms were used for classification, mainly J48, Hovding tree, random tree, and random forest. As the dataset was already small, for validation purposes, we used a tenfold cross-validation. The classification results suggest that the best performing model is the random forest with 93% of correctly classified instances, followed by the Hovding tree with 85%, J48 with 76%, and random tree with 75% of correctly classified instances. In terms of the mean absolute error, the lowest mean absolute error was found for the Hovding tree, followed by the J48, random tree, and random forest. When observing the results of classification, we should observe the values of precision, recall, and F measure. And these values should be close to 1 in order to indicate good classification performance. In this case, we can see that the random forest obtained the highest values of precision, recall, and F measure comparing to the rest of the models with the values of 0.93. To better understand the results of classification, we can look at the classification matrix. Here we have a classification matrix for each of the models, and we can observe the numbers in the diagonal, which represent the correctly classified instances. However, the rest of the numbers in the rows and the columns represent the misclassifications. So, for example, for J48, we can see that 6 images that truly belong to the monasteries class were misclassified as frescoes. Additionally, 6 images that truly belong to the frescoes class were misclassified as monasteries. We can observe similar for random forests, for example, where 3 images truly belonging to the archaeological sites were misclassified as frescoes. So using the confusion matrix, we can see where exactly the algorithm is making mistakes and which classes it mostly confuses. These results suggest, however, that decision trees, in particular random forest, can be used for image classification of a small sample. Thank you very much for your attention. More details about this research can be found in the following publication presented at the first International Workshop on Visual Pattern Extraction and Recognition for Cultural Heritage Understanding.